ठीक ब्रो। Hello, people. How are you doing?
Talking to me or Cole?
Talking to all y'all. How you doing? You guys good?
Yep, doing good.
Good, 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 good.
Let me get rid of my face here.
Please don't get rid of your face. I like it.
No, that face. Okay, I'll use this one. Is this one better?
Sure. Did everybody have a good Easter?
Yes.
Yes.
Great
Excellent. Still miss you guys. Can't believe we're still doing this. I don't think we are anywhere near the end of it, though.
That's sad.
Yeah, we're going to be a bit, I think. All right, let's see. Give everybody else a chance to get back. I think there were some people who were here, but then skipped out because I see some screens. Got a couple of people with no face. That's fine. All right. Good deal. Yes, Shannon, I did. Shannon's asking if I streamed the video conference to Facebook, and yeah, I did. It's kind of cool. We can do that now. All right, so hello, Miss Mary. Welcome around your house. All right, let's go ahead and start. What happened? Oh no!
Mom, calm down.
What happened? Did my mic go crazy again?
Your mic just went.
I'm not doing it. All right.
That was a bit crazy.
Sorry, y'all. Okay.
Right as you said sorry, y'all. She just said y'all. Went.
Okay. Well, bear with me. All right. So this week's lesson's on chemical reactions, but I wanted to show you guys one first. So we had a bonfire on Friday. Was it Friday? No, Saturday night. And I took advantage of my supply of chemicals. And can y'all, whoops, hang on. Did I share that? I'm going to share my screen and I want you guys to check this out. So, somebody's coming in. Hold on. Come on, Dylan. There's Dylan.
This was so much fun.
Yeah. So what I did was, and we'll probably have some fun with this next year in chemistry, but I went upstairs to the schoolroom and I got some chemicals out and I brought them down and I threw them on the flame because I knew what they would do. So I wouldn't recommend doing that if you don't know what they would do.
It's copper.
No, you just ruined it. I was gonna ask everybody if they wanted to guess what it was, but anyway, this is what copper does if you throw it right on the flame.
All your friends, that's why they don't miss chemistry. You got it going?
Oh, yeah, we're putting colored stuff in there. Wow.
Pays off to be homeschool science teacher, right? All cool stuff.
Kind of slow.
Oh, that's cool. Harry Potter.
Yeah. It's blue powder.
Very Ireland.
It's like a big scoop. Big scoop.
It's a good scoop. I'm gonna go right in the middle with it.
Wow.
I'm gonna go right on the right here on the edge, Cole. So now it'll come around. Get the wood.
Just pour the whole thing in.
No, it's better to make it last longer.
So that's interesting, right? Kind of fun.
What do you think would happen with the glass bottle that was in there?
And then, of course, Drew wants to light a glass bottle on fire. Let me pause that so it stops playing. Okay. Yeah, there we are. So anyway, we had green flames. It was kind of cool. So that's something you can do if you've got extra chemicals on hand and you know what they'll do. And it's still playing. I told you to stop playing. So that's interesting, right? It's still going. It's looping. Oh, y'all, I'm so not good at Zoom yet. And then, of course, Drew wants to light a glass bottle. Hang on. Oh, I know what it's doing. It's looping that back around. Yeah. Go. There we are. Maybe. So, anyway, we had green flames. Oh, fun. So that's something you can
Just
do.
pause the video.
Sure.
No one can see it. Just pause.
It's doing,
and we won't hear it.
what it's doing is it's playing my live lesson over here. So I'm gonna close that. There we go. Oh, there's Delia's face. Hey, Delia. All right, so I'm gonna go ahead and we'll start today's lesson. I just wanted to show you cool green flames because that's fun, because why not? So, okay, let's see. Where is my, look at all my fun stuff going here. I got everything going. So here's our lesson 32 for today. And hopefully these don't get too terribly boring because we're sitting here with, you know, no lab to do in person. Y'all saw that I recorded last week's lab because that was your assignment. And I did this week's lab as well, right? So it's going to be the same kind of thing where you watch and then answer questions. So let's see. First off, I wanted to show you something not quite related to chemical reactions, but I saw it this week and I wanted to share it with you guys. And it was this. Would anybody like to comment on this? Oh, come on, Michael. I know you have a comment.
No.
Glaringly wrong with this?
The dates of the viruses?
They might be wrong, but I know for sure this first statement down at the very bottom here, like, oh, radio waves introduced in when? That ain't gonna work, is it?
No.
Yeah.
That's just not
You
true.
can't fix stupid.
Well, yeah. So anyway, this is going around, and it's going around because 5G just got launched in certain places, and people are like, oh, well, what a coincidence. So my comment on that was this handy dandy little thing I found produced by the World Health Organization. Viruses cannot travel on radio waves or mobile networks. I hope you, you guys, these people vote, right? All right, COVID-19 is spreading in many countries that do not have 5G mobile networks. Surprise, surprise. COVID-19 is spread through respiratory droplets when an infected person coughs, sneezes, speaks. People can be affected by touching a contaminated surface, right? So this lady who posted this was this lady named Mary Ellen. I don't know who she is, but my lesson for you guys is don't be like Mary Ellen, because no, yeah.
Face.
Yeah, don't be like Mary Ellen. My entire goal is to make you not scientifically illiterate, right? Because that's scary. Like, remember the one from earlier this year where there was this survey where all those people said, what was it? I can't even remember the percentage, but all the people who said they wanted to live in a world without chemicals. That was fun, wasn't it?
That was amazing.
Yeah,
That was amazing.
straight up
All the
awesome.
ones where people thought chocolate milk came from brown cows.
That one's fun too. That's a really fun one. Chocolate milk comes from brown cow. It doesn't?
What?
All right. All right,
it does.
moving on. All right, so here we go. Actual lesson now. When learning about chemical reactions, it's important to remember this law. What is the law that states that matter is never created nor destroyed? If you know it, go ahead and unmute yourself and pipe up. Go ahead,
The
Michael.
law of conservation of mass.
There you go. Law of conservation of mass. Okay, so matter, actually, because matter is never created or destroyed. That's the law of conservation of matter. So to follow up on that, so there's our law of conservation of matter, because matter is never created nor destroyed. So when we're talking about matter, remember that it's anything that has mass and takes up space. You guys know this. So this is the law that applies to chemical reactions. And this states that mass is never created nor destroyed. So that's it, right, Michael? Law of conservation of mass. So if your law of conservation of matter says matter can't be created or destroyed, and matter is anything that has mass and takes up space, then logically your next step is going to be that in a chemical reaction, mass is neither created nor destroyed because mass is conserved. So there's your law of conservation of mass. Go there. All right. So in the chemical reaction, blank are either broken or formed. Anybody want to give us a guess there? Go ahead if you know. I can't see all the hands at one time, so. Anybody know? Okay, so it could be chemical bonds. Chemical bonds are either going to be broken.
You know people can raise their hands on Zoom.
Yes, they can, but I have to, in order to see my screen and all your faces at one time, I kind of have to, oh, you're doing that way? Yeah, if you want to do it that way, that's a great way to do it. So tell everybody how you just did it. What did you?
Participants, and then click raise hand in the bottom right of that window.
There you go. Which window were you in?
Participants.
Participants. Okay, so if you go to participants, you can raise your hand. Do you see it? Okay, and I get, when you do that, there goes Delia. When you do that, I get a flash on my screen. Otherwise, I have to scroll all your little faces and look for your actual real God-created hands, which are beautiful, but they don't flash up at me. So there we go. All right. So this should be interesting because I'm going to have an example, 2 example chemical reactions for you that I've written out as an equation, and we're going to work through those today, just so you can see how they work. So here we go. When we're looking at our chemical reactions, we've got bonds. Whoop, I clicked that early. So bonds are either created or broken, formed or broken. So breaking bonds is going to require energy, and forming bonds is going to release energy. So if your energy is absorbed by a reaction versus your energy is released by a reaction, what do we call them if your energy is absorbed by a reaction? Anybody want to try the hand raise thing? Give it a shot. Nobody? All right. How about this? We're going to pretend energy. We're going to not pretend. We're going to use heat and think of energy as heat because that's what we're dealing with here, really. So here you go. If your energy is absorbed by your reaction, it is endothermic. All right. And you can remember that because endothermic feels colder than the surroundings. All right. So if have you ever broken one of those little ice packs that everybody goes to the nurse for at camp, and you shake it up and it gets really cold and it feels colder than the surroundings? There's your endothermic right there. So what's it going to be if the energy is released in a reaction? It's going to be, yeah, Cole?
Mom,
What?
something just came down on your phone. It's from Amazon saying that your package will come later today.
Hey, we're good, Drew. I don't need the update on Amazon, but thanks for letting me know.
Sorry.
Cole, were you going to say exothermic?
Yeah, exothermic reaction.
Very good. So an exothermic reaction is going to what? It's going to feel hotter than its surroundings. So this is the opposite of those little cold packs. If you've ever been out in the winter and you buy the little heat packs, you ever seen them? They're really cool. And you do the same thing. You break them open, break them inside and shake them up and they get warm. They're great if you're out in the snow and you're skiing or whatever. Keep your hands warm. All right. Same idea. So here's this chemical equation. Sorry, I'm gonna try and move you where I can see my whole screen and you guys. All right, so for this chemical equation, I'm gonna be using these 3 different elements. So you remember that C is carbon, H is hydrogen, and O is oxygen. And those are their chemical symbols. I'm not making them up for fun. All right, and here they are, okay? We're gonna have 2 reactions here for you guys to see. So does anybody at this point want to take a guess as to what they might be? We're going to take multiple guesses as we get closer and closer. Okay, no. So we also have coefficients. That tells us how many molecules. Okay, so sometimes you're going to have maybe an oxygen molecule, which is just 2 oxygen, or sometimes you're going to have oxygen as part of another molecule. Now the coefficients go in front like this. They're big numbers, okay? There's going to be a lot of this next year in chemistry. Remember, we're just touching on all this chemistry stuff at the end of our year of physical science. So look right here. Does anybody know what that is? CO? Anybody know? Let me ask you this. What's CO2? Does anybody know what CO2 is? I know you guys know that. Somebody knows. Cole.
I do.
Wait a minute. Cole raised his hand. Go for it, Cole.
I
Carbon
did.
dioxide.
Carbon dioxide. Right. That's CO2. So what do you suppose CO might be? Think about that prefix before dioxide. So this is carbon. Right.
Monoxide.
Yeah, there you go. If it stayed right here as just CO.
My hand is raised.
It is now. It wasn't a second ago.
It was.
I didn't see it. Sorry.
Raise it virtually.
Yeah, virtually. I can't see. I have to scroll all the faces to look for real hands. Do you see how to raise it virtually, Drew? Not
Click
like
participants on the bottom bar, then click raise hand.
you see what Henry's showing you? Give it a
Oh,
shot.
like this?
Yes, Drew,
Yes.
you got it. Anybody else
Okay.
want to practice real quick? Anybody else want to practice it? Somebody else just did. Oh, 3 people, 2 people. Wow, everybody's doing
You
it.
have to lower your hand though if you raise it virtually. If you use
Yeah,
that. So once you're done, make sure you
lots
click it
of them.
again.
Okay, good.
Oh.
I see lots of people. Awesome. All right, so our coefficients tell us, there you go, Drew, how many molecules. So what else do we have? We also have subscripts, and they tell us how many of each element. So like we were saying, sometimes there's more than one atom of a particular element within a molecule, right? So for example, what we were just saying was carbon monoxide is actually what? Carbon dioxide, right? What's this one right here? Somebody knows. Give me a hand.
Or
Oh, give me a hand. Where are my hands? Somebody said it. Was that, Drew, what is it? Drew, what's this one right? What was this one right here? Your hand went up. Oh, somebody else. Who else is up? I can't see. It's hard to see all these.
Jackson.
Jackson, what is that, Jackson?
It's water.
That's water. Very good. Okay, so we've got 6 carbon dioxide and water. And then over here we have some other stuff going on.
I was on mute. Sorry.
Oh, okay. All right, so let's see what else we have going on. All right, now we have these little arrows. These arrows belong here. And these arrows mean, it's sort of like an equal sign. We call it yields in chemistry, but it's very much like an equal sign. So what we have is 6 molecules of carbon dioxide plus 6 molecules of water. And then there's going to be energy here in the form of sunlight. That's where this is going to go on this side of the equation. And we get this yields, right? 6 molecules of glucose. That's what this is. Does anybody know what glucose is? Anybody want to give it a shot? You ever heard of glucose? Cole.
it's in sugar, right?
It is sugar.
Oh,
Okay.
yeah, sugar, right?
It
Yeah.
is sugar, right. It's a type of sugar. There's lots of sugars. There's sucrose and glucose and fructose and lots of sugars. But glucose is
Lactose.
sugar. Absolutely. When you check your blood sugar, you're checking blood glucose. And then what's this last one? Plus what? That one's easy. Anybody? It's just O. So what is it?
Oxygen.
Yes, there you go, oxygen. Oh, but you know what? Savannah's hand went up. So next time, throw your hand up first. All right. So this is what we have on the top. 6 molecules of carbon dioxide plus 6 molecules of water yields 1 molecule of glucose plus 6 molecules of oxygen. Well, look at the bottom. 1 molecule of glucose plus 6 molecules of oxygen yield 6 molecules of carbon dioxide plus what? Go ahead, Drew.
Oxygen plus the sugar.
Yep. Yields what?
Sugar water.
No. So we have carbon dioxide plus 6 water, and it says plus energy in the form of ATP. In this one, we had energy on this side, and on this one, we had energy on this side. So what do we notice about this reaction and this reaction? What do you guys notice? Nobody noticed? Do you guys notice that they're opposite? Look
Oh.
close. Carbon dioxide and water yields sugar and oxygen. Sugar and oxygen yields carbon dioxide and water. Okay, what in the world are we talking about here? There it is, right? Carbon dioxide, water, glucose, oxygen, carbon dioxide, water. What's going on? So on this side, we call these the reactants, right? These are the things that are reacting. They're the reactants. What do we call the stuff on the other side? The things that are produced. Anybody? Yes, Jackson.
Aren't they products?
Yes, sir. They are products. Excellent. All right. So we have reactants and products. So in one of these, the reactant from one is the product of the other. And in this one, it's the opposite way around, right? All right. So here we have these equations again. This one you see the energy is going in because it's on the front side of that yield sign. The arrow is not pointing to it, it's leading into the arrow, right? So if the energy is going in, it's going to be endothermic. And in the one at the bottom, you have the energy going out because it's on the opposite side of that arrow. So it's going to be exothermic. There's going to be a lot of this next year, but it can get really fun. So does anybody want to guess what these are? They're very familiar chemical reactions. You're experiencing them right now, I promise you, all around you. Maybe inside you, definitely inside you. How about that?
Breathing, your lungs turning oxygen into putting it into your body.
Okay, we're getting somewhere.
Bloodstream, sorry, into your bloodstream.
We are getting there, yeah. So we call this top reaction photosynthesis. Where does that happen? Drew.
Finally, I got it. It happens with plants when they use the sun to recharge themselves, basically.
Correct. Remember we had energy from the sun over here. So plants are going to take in carbon dioxide and water, and they're going to produce sugar and oxygen. What they do is they store that sugar. That's what you eat when you eat a fruit, right? Or a vegetable or a leaf or whatever. And they're going to release that oxygen. You know how some people say that trees breathe out oxygen? Okay, so then if that one's photosynthesis, then the one at the bottom, Cole was on the right track. This is aerobic cellular respiration. So what that means is this is exactly what happens within your cells. Your cells are going to take in sugar, which is your fuel, right? And oxygen, which you breathe, and you're going to produce carbon dioxide and water. They are opposites. That's why it's so important that we have trees and other photosynthetic organisms around us to help produce our oxygen. Does anybody know where most of our breathable oxygen comes from? Anybody want to guess? Drew?
Photosynthesis.
The ocean.
Photosynthesis and the ocean are my two guesses here. Okay, how about we take a vote? Can y'all vote on your thing where it says participants? I don't know.
Ocean.
Ocean, he says. All right, let's do it this way. Put up an actual hand.
We could vote in chat.
You can vote in chat. Yeah, I thought you could, but I have to keep switching my screen around and it's hard for me to see everybody. So let's do it this way. Put up an actual hand if you think it's trees. Let's count hands. Most of our breathable oxygen coming from trees. Uh-oh, I lost your faces. There we go. Let's see, I got 1, that's Lily, 2, Eleanor, 3, Jack. All right, and Savannah, 4. So then the rest of you think it's ocean. Who's that? Who thinks it's ocean?
Actually, I just realized it's probably ocean.
Okay.
So I'm gonna do ocean.
Dylan and Drew. So technically it's organisms within the ocean. So most of our breathable oxygen
Bro.
comes from phytoplankton, diatoms. Put that up, Drew. So these are organisms that produce oxygen, and most of it is coming from there. They're tiny, tiny, tiny little organisms, but they're what keep us breathing. All right, so we got some types of reactions and some examples. All right, we're going to have what we call synthesis reactions. That's 2 or more simple substances combined to form a more complex product. All right, so an example of that would be when sodium and chlorine combine to produce sodium chloride, that's NaCl. Sodium chloride was in last week's lab, right? Does anybody know what sodium chloride is when you see it like this? NaCl? Anybody? Hands. I'll have to open this chat. It's just hard for me to see them. Delia.
A chemical?
Yep, it's a chemical. Do you know which one it is?
No.
Who else has got their hand up? Let me see. How about Dylan?
Salt.
It's salt. Yeah, it's table salt. It's a salt. One of many salts. Okay, so there's going to be a lot of salts that are similar, and what I mean by similar is when you look at the placement of these 2 elements on the periodic table, there's like potassium chloride and sodium chloride, and but yes, so a salt. Very good. And let's see, how about decomposition reactions? That's when you have a single compound that breaks down into 2 or more new compounds. So here's a good example of this one. You got carbonic acid, which is H2CO3. Same stuff that was just in we just did respiration and photosynthesis, same elements, right? Go figure. So, and that's an ingredient in soft drinks. And a decomposition breaks that down. When the carbonic acid breaks down, it makes water and carbon dioxide. So when you fizz in your drinks, it is in part because they have put carbonic acid in there. And it breaks down to release the carbon dioxide. It's also the thing in drinks that can rot your teeth just as much as the sugar. So even if you have diet soda, sometimes that'll still get you, right? And then combustion, that one's obvious. That's when you burn something, and one of the reactants is always oxygen, right? You got oxygen in the air. Fire needs oxygen. Fire needs two things. Fire's like a living thing almost. It needs two things to survive. Does anybody know what they are? Drew?
This isn't about that, but Aunt Ducky no, seriously, Aunt Ducky just said they have power back on and they have a dent on the car.
Okay, thanks. My best friend lives in Virginia Beach. They had terrible weather and trees like fell all over her house. She's all right. Thanks.
Fire needs fuel and oxygen.
Thank you, Cole. Fire needs fuel and oxygen. So combustion, one of the reactants is going to be oxygen. Whatever the other thing is the fuel. All right. Thanks for the update, Drew. How about single replacement? So that's when you have an element that reacts with a compound and takes the place of another element in the compound. Whoops, my fingers wiggled. So potassium reacts with water, for example, and a colorless solid compound named potassium hydroxide. And then the last one would be our double replacement. And that's when you have two compounds that react, and the positive ions, remember those we call cations because they're the cutest, they're positively the cutest, right? And the negative ions, which are the anions, the onions with the bad attitudes, is so terrible, but it works, right? Switch places and form two new compounds. So here's an example over here. It says the reaction of, this is a good one, sodium bicarbonate and acetic acid forms salt sodium acetate, the salt sodium acetate, plus carbon dioxide gas and water. And this is what the reaction looks like. Does anybody know what sodium bicarbonate and acetic acid are? I guarantee you've seen them react. Either that or you've lived under a rock for how many years? No? Nobody wants to guess? Even a guess? All right, I'll give you a hint. Acetic acid is in vinegar. Does anybody want to guess what the sodium bicarbonate is? Come on. Dylan.
Baking soda vinegar.
Thank you. Baking soda and vinegar. So if you've ever seen baking soda and vinegar react, and you've seen the fizz and all that good stuff, that's because you're getting carbon dioxide. That's the gas that's released. And then there's some water left over, and it produces a salt. We'll find out next year when we do more in chemistry that when you put an acid and a base together, you always get a salt as a product in the end. You don't really notice it when you do those little, volcanoes or whatever it is you do, but it's there. All right, so that is that. And I wanted to show you guys real quick a couple of other things before we are done for today. So you guys know that you're going to, what's the word I want? Wow, just went right out of my head. That our schedule has changed to only these Tuesdays at 11 o'clock, right? And then we're gonna have our final exam. I had it pulled up and I dropped it. But I'll pull it up again real quick. Our changed syllabus, did everybody get that? Our updated syllabus that we had to revise it? Eleanor, you got a question?
Yeah, I was wondering how many more lessons until the final exam?
Perfect question. Okay, so that's where we're going. So here was today, right? This is today's lesson, right? There we go, make it a little bigger. All right, y'all can see that, right? So here's today's lesson. This is what we did, and then what you guys still have to do is go watch Lab 32. I think that says Lab 31, and that's wrong. I should have said Lab 32 here. I was redoing it all. Oh, you guys, whoops. So anyway, you got to go watch Lab 32 online. All right, same thing as before. Same thing as last week where you're going to go online and answer questions.
Spell my name wrong.
Where is it? What? Whose name is where? Who saw it? Oh, are you guys talking about the chat? Okay. All right. So the last chance for late work was at right after midnight this morning. So I haven't graded that yet. I'm going to check. Your last chance for extra credit is today. That's 11:59 p.m. So remember, the extra credit was make another video like the ones some of you guys did before, of any of the topics that are left over. And I've created a file in our private YouTube page that has all those videos in it for final exam study, okay? So Eleanor, today is the last day for late work, and today, well, that's already passed, but there's still a chance to turn in an extra credit video by 11:59 p.m. The basically the standards for that are the same as they were for the option B videos. All right, so then we have lesson 32. That's next week. Same time, same place. Here's our Zoom information, right? And what I'm gonna do for lesson 33 is because this is acids and bases, so I'm gonna try to do a little bit of a live lab, not a whole one, but like a little bit of a live lab and show you some actual reactions in live time, because that's more fun than watching the YouTube videos. Plus the YouTube videos take me like hours, that's okay though, but still. So then here's where it gets interesting. Then we have this one more class right here. And this is on the 28th. So that's the last Tuesday of this month, right? It's lesson 34. But if you look right here, it says skim over your textbook sections. Skim over them. This is not a big thing. This is just look over it, be familiar with it. And if you look for during class, it even says review lesson and a quick class discussion. So, I mean, it's going to be quick. You don't have a test for this lesson. There's no test for lesson 34. So you have a lesson 32 test, a lesson 33 test, and then there's no more lesson tests. That's it, okay? So you're nearly done with those. You also don't really have anything to hand in here. You're just going to skim over this, be familiar with it, so you know what's coming next year. Then our final exam is from 11 to 1. Now, here's what you guys need to know. It's going to be in TeacherEase. It's going to be online. It's going to be open at 11. It's going to close at 1. And you have 90 minutes in which to complete it. That's a 2-hour window. So that means if you want to take a 15-minute break or a 20-minute break and look over your notes one more time or whatever, you can do that. But starts at 11. Boom. So this class is going to be early. This class comes at, I think it was 10. I don't know, 10 o'clock for this class. So we're gonna meet early, we're gonna breeze over some stuff, then we're gonna do this final exam. Delia, do you have a question?
Are the rest of the classes gonna be at 11 o'clock?
Yep, except this one. So lesson 33 and 30, well, really it's really only one more at 11, because this is 32, next week is 33, that's 11. 34 is going to be at 10 because at 11 is your exam, okay? Now, you guys are just going to do this online, roll through it, and then you have until the 5th to turn in your final project. Now, this was the Rube Goldberg machine, right? And we were going to do them as teams, but that's obviously not going to work because we can't touch each other, be near each other, breathe the same air. So did everybody see the new assignment came out? Did everybody see it? I put it out with the new details. Henry, got a question?
Yeah, so the TeacherEase, whenever I try to like do the online lab, it still gives me that error.
Okay.
I've like tried it on multiple devices, like disabling my VPN, like pretty much everything.
Which lab was that? Was that 31 or 32?
Lab 31.
Okay, let me go back and look at it, but if you want to just send me handwritten answers, did anybody else have a problem with lab 31? I don't know.
It's a nondescript error, like
That's weird.
you've
Yeah.
been notified and we're looking into it.
Yeah, I can't see that on my end. It looks fine. Like I know, Jack, you guys had some trouble getting the right lessons downloaded, right? But I could see them on my end. And then I saw that your mom had sent an email this morning, but I didn't get a chance to read it yet. So I don't know. Did you guys get it worked out? Oh, you're on mute, I think, honey. There.
We just
Yeah. Did you get that worked out?
we just tried to figure it out the best we could. I think I did have the right ones, but it was weird.
Okay. Yeah, they look different the last couple lessons because we're just skimming stuff. So I just pulled some online resources rather than writing them out like I usually do because, you know, things are different now that we're all scattered like this. All right, so you guys are going to get me your videos for your Rube Goldberg projects. I've already gotten Michael's, and Drew's is almost done, I think. And so I know Cole's worked on his. I don't know who else is working on theirs, but I don't know how long Michael's took for you to do, Michael, but I think Drew's took what, maybe 2-3 hours total? And I think Cole's is probably about the same. Let's see, I have some hands up. Henry, you got your hand up?
Got to lower it, my bad.
That's okay. Dylan, you have your hand up?
Yeah. So what was the new final project?
So you're doing the Rube Goldberg on your own, but I changed some of the standards so that it wasn't kooky because there were some things that were going to be more geared towards a team, and I altered it so it could be done one person at a time. I'll go over it with you guys real quick before we leave. Who else? Eleanor, you have a hand up?
Yeah. I was wondering, do we have to like do it right now and then send you the video, or do we do it while we're on Zoom on the last class?
Okay, so you're gonna send it to me on video right here before the 5th, anytime before the 5th, okay? Send it to me on video anytime before the 5th. There's a link, you can send it through on Teacher Ease, but like Michael said, it only let him send one file, so like he emailed one, and that's fine, just get it to me. And then I'm gonna put them together and cut out any like dead time or whatever. And
I
that's
sent an image to the
Henry, what?
error. I sent a link to what the error looks like in chat.
Well, thank you for telling me. I don't know how to fix it, but I'll try. So our final party, our watch party, okay, this is gonna be when we usually would have had our competition and gone to the swimming pool and had snacks. Keep doing that. So we're gonna have a watch party. So we'll do it here on Zoom, and that way you guys can comment and chat and whatever else. And I will run all the Rube Goldbergs back to back to back, okay? And we can watch everybody's own machine that way. And that'll be hopefully something. Bring some snacks and I don't know, wear your PJs. We wear them every day anyway. We're homeschoolers. I don't care. Whatever you want to do. But I will add, I will take bloopers. If you have bloopers you want to send me, go ahead and send me some bloopers and I'll throw them together and maybe that will be fun. Maybe that'll be something else we can do. Let me show you that project real quick, but I got 2 hands up. Dylan, your hand's up again?
I just forgot to lower it.
Okay, Delia, yours is up?
What bloopers?
Okay, so sometimes when people make movies, they make bloopers by accident. It's just when you mess up and it's funny. Like you look back at yourself and you're like, oh my gosh, did I really do that? I actually managed to make myself an entire blooper reel this week because I had to do a bunch of chant for church and some of it was just horrible. So it made me laugh and I had a blooper reel. At least I amused myself. Let me look real quick at that. I didn't have that open because I didn't plan on it. Where did I stick it? I think I put it, did I put it in labs because it was a lab? Yeah, here we go. All right, so here's the final project one more time. So I know you guys got this by email. You can see it through Teacher Ease. So this says revised right here, right? It's revised. So your task is to build the machine. You're gonna work alone or with other currently enrolled siblings. So if you've got a household full of people, cool, work together. You have to build machines everywhere, make your parents crazy. You gotta utilize at least 5 transfers of energy. It has to have a maximum runtime of 2 minutes. The reason I say that is because we did one years ago and it started with water filling a bucket and that took like 2 minutes for the water just to fill the bucket. It was a really boring video for a bit there. So you gotta have at least 4 of the 6 machines. You can include a machine more than once, but it doesn't count towards the 4, okay? You have to have, each transfer of energy has to be intentional. That was in the rules before. Like you can't have something go awry and be like, well, it worked. The machine, if it has a mechanical part, it has to be electrical part or mechanical part. It has to be activated by another part of the machine. So you can, like, if you're going to start your energy, obviously you can do that by pushing a ball or whatever starts it. But if you're going to have like a fan turn on, you're going to need some part of the machine to do that. You can purchase stuff, but don't spend more than 15, because otherwise, you know, somebody will spend $200 on their dream machine and somebody else will have like an old pair of sneakers and a golf ball, and that'll be it. That gets ridiculous. No restrictions on your height or your space. Just check with your parents, please. You can put them indoors, outdoors. They can go in and out. I don't care. Nothing dangerous. And be sure that you get your folks' permission for every part of this. Like, don't, you know, take over their house one day and have things flying all over. And then remember we had a spokesperson before? So now you're gonna do it. You have to walk through, make a quick video, and it'll be like, you know, this is where my machine is gonna start, and I have elastic potential energy with this rubber band, and when I let it go, it's going to trigger this ball, and once the ball starts moving, it has kinetic energy, it's gonna go to here, that kind of thing. But you gotta do it quickly, 1 minute. And then film the machine in action, 1 shot. So the only exception to that is, say you're gonna send like a bucket down a hill and you need to get video of where it ends up at the end. That's okay, but you know, there's very specific rules about that here. What I don't want is like all parts of the machine filmed separately, because then we don't know if it actually worked, right? Camera tricks, camera tricks. You can trigger it as many times as you need to make it work, and don't be rude, y'all know that. So due by Tuesday, 11:59 p.m. By 11:59 p.m., send them to me in MP4, upload through the final project assignment on TeacherEge. I said no exceptions, but the exception will be if you've got, like, the video won't upload, like Michael had that issue. One uploaded and the other didn't. He had 2, because he had his walkthrough and then he had the machine. And I'll see if I can make it put in a separate link for submitting, but I don't know if it will, because I've never used that one before. All right, and so that's that. Here's your grading rubric, it's attached. I also attached like a checklist, and it's a little one, but it kind of keeps you on task. It's not as detailed. You can't depend entirely on that. Last thing I want to show you really quick, and then we're gonna get going. You guys can go do the rest of your day. So I have put this in the digital locker on TeacherEase. This covers all of the topics for the final. Hang on a sec, Dylan, I'll get you. So I have a video link for each of these, as well as the lesson. So this is where you will find this information. So here's the topic, right? These are the topics up here. You'll find these lessons will contain this information. But if you need to watch something to remind you, here are videos. Some of these videos are ones we made here in class. Others are just good YouTube lessons, but that's because I'm not seeing you face to face. So I don't have the opportunity to kind of do what some of these videos do, more the live teaching. But these are all the topics. The only one I don't have a video posted for yet is this one right here for Newly's Principal, because Sky's working on that currently. All right, so as soon as hers is in, that'll go here. So I have this already in your digital locker, easy to find. Once you find it, you're good to go. Dylan, you had a hand up? Let me see. Yeah, Dylan?
Yeah, I remember last year you sent out like a final grade calculator type thing. Are you gonna do that again this year?
Would you guys like for me to do that? Would that be helpful? So what I did last year, for those of you who weren't with us last year, is I took your current grade as it stands and said, for the final project, if this is the grade if you get this grade on the final project, then your final grade will be, and I did like a scaling. I can do that again. It will be a little more difficult, only in that we've got a week between our exam and the final, and I'm gonna have to grade the exams to get the best starting point data for you all, and then I'll need to get that information to you, but you will already have your videos. Well, you'll have a week to get your videos turned in. So I can give it a shot. I think I can probably do it, Dylan, if that's good. Delia, you have your hand up?
What's the deadline for the projects again?
So the Rube Goldberg videos are due on the 5th, May 5th. Is that all you need?
Yes.
Okay. How about Sky? Did you have a question?
I sent you my video last
Yep.
night.
Perfect. Thank you. I hadn't checked yet. Awesome. I can't wait to see it. Your last one was really good. So you guys should watch all the videos your classmates did because they are really, really helpful in understanding the concepts. Everybody did a really good job with them. I was quite pleased. And remember, if you have done those the first round of videos, if you did that option B, that you don't have to do labs from here on out. You don't have to turn anything in. I would like you to watch them. Watch the video so that you kind of know what happened, but you don't have to turn anything in, okay? And then the last thing I wanted to show you guys before we split is, aside from the final exam topics, which are in the digital locker on Teacher Ease, there's also this, which I put in Teacher Ease digital locker. Remember these guys? Oh yeah, these friendly guys, okay? So these are things to try and help you guys remember what you will need to know or what you should be familiar with. And I will say, these right here, these math-oriented ones, definitely geared more towards the lab rats than the junior lab rats. But the ones that are the real basic ones, juniors, like this one, this guy here, and maybe this guy here, these are the ones you really need to remember, okay? Does anybody have any questions for me before we disappear onto our own week? Miss Lily, I saw your hand.
Which ones do you have to memorize again? Sorry.
I would look, if I were you, I would look, whoa. I would look at this one here, the force mass acceleration, and then probably this distance, time, and speed.
Okay.
Those were back at the very beginning. Delia,
Okay.
you got your hand up, honey?
Where do we find the videos from everybody else?
Okay, so there's a couple different places you can find them. If you go straight to our private YouTube page that you can get to through our website, or you can get to through, there's a couple different ways to get to it. And the other thing is, if you go in the digital locker, I've posted that document with all the topics with each video linked to the topic. So if it's a topic you know really well, it's like, psh, I don't need to look at this one again. Also, I put it in our forum. So there's lots of places where you can go and find it. And Shannon, don't panic about the final. The other thing you should remember about the final, and this was funny because it was the same thing with our midterm. Remember that the final doesn't weigh more than any other test. I want you guys though to understand the importance of the cumulative knowledge and rather just the weekly checking in. Some of that stuff should be retained, or a lot of that stuff should be retained. So that's the point of a final, is kind of to look cumulatively at the whole year and go, okay, what did I learn for this year? And you know, most of you are not in a teetering position where if you didn't do well in the final, it would tip you one way or another for a letter grade. So still important, but not worth a panic. I saw a hand. Whose hand did I see? Is a hand down now? Oh no, Delia.
Is that also where we find the videos of everybody else's projects too?
You can see them there. I do have them there. Go away. Where is it? Sorry, I'm messing with it over here. Yeah, so yeah, that's where you'll find the videos for other people's projects. You can definitely see them there. And that's a good place to start. Good place to look. Why do you keep doing that? Go away. There it is. So who else has a question? Does anybody else have a question? No? Are we good? I still miss you guys. This is crazy.
Me too.
I know. We're all super lonely, right? And it's like,
Cause
Have you found something cool to do to occupy your time that maybe you'd like to share that the rest of us can go, oh, awesome, we can do that.
Learning guitar.
Learning guitar? Is that you, Michael?
Yep.
All right. Lily?
I've been working on a big Lego boat.
Yeah? Lily, did you find
longboard.
something fun to do?
I longboard.
You longboard? Really? That's amazing. Wow. Anybody else find anything fun? Yeah. Lenore, did you find something?
I've been writing a vampire story.
No way. I want to read it. That sounds really cool. A vampire story.
This is my big boat.
Yeah, so we sorted our Legos, well, mostly I sorted, into
No, not
all these
true.
containers, and Drew stole some and made himself a boat. Really pretty cool.
It's got a submarine and everything attached to it.
Mm-hmm. Very good. So I hope my work is something that's keeping you busy, but not overly busy. I don't want anybody to have nothing to do, but at the same time, like, I also don't want you to be slammed with ridiculousness. I'll tell you what I don't want you to do. I don't want you to do what the teenagers in my neighborhood did last night. I told Colin.
Oh God.
Yeah.
I would have punched that dude right
No,
in
you
the
would not
face.
say
This kid, from the way mom and dad have described him, he would have punted you into the neighborhood pool.
Yeah, so
okay?
we went down to, we were taking Ozzy for a walk, which, by the way, Ozzy's been sleeping in my lap this whole time, sleepy dog. But we took Ozzy for a walk, and we went down to, you know, like where our clubhouse and stuff is, and you're not, like, the whole amenities area is closed. You're not supposed to be on the equipment or on the courts or whatever. So we were just walking around, and there was this group of teenagers down there playing basketball, doing a very poor job of social distancing. I mean, very poor, touching all over each other, touching the equipment, and we were like, ugh. So we just kind of ignored them because I don't know them, and maybe their parents are like, sure, go be sick. So then we went over and looked at the water on the dock and walked back, and I was like, Jason, look at them now. And he's like, oh, don't worry about them. I was like, no, look, they were burning stuff on the sport court. There was a legitimate fire, y'all, like 10 inches tall, flames. And so we were both just completely taken aback and walk over there, and we're like, what are you doing? So then we had to address them, and then it became a big thing. But since this is a live stream, I don't want to share what happened. But it became an event. But yeah, I muted you for a reason, Drew. You're muted, and don't unmute yourself because you're good. No. Anyway, anybody else have anything they want to share? Do you want to
across the boat.
If you want, I'll give you a few minutes to chat, and I'll take your live stream off. Would you like that? Do you guys want to chat again like last week?
Yeah.
Okay, I'm gonna kill your live stream now. All right, and you guys can go ahead and chit chat with each other for a few. I'll just leave this up and running, but I love you all and I miss you, and I hope everybody stays healthy, okay?
Goodbye.
All right, y'all chat. Bye.
I would have, they said mind your own.
Drew. No, we're not doing this.
Someone press Alt F4. There's something really cool that happens.
Oh yeah, do it.
You fools, I'm on Mac.
Hey,
Who here's on PC using a
oh,
computer?
PC gang, dude.
Whoever's on
You should opened up my launch pad.
Saba.
Michael, how do you download Call of Duty Warzone?
Dog.
Go to the website, I'm pretty sure, right?
No, it's on Blizzard. The
Oh.
Blizzard launcher.
the same, the Overwatch launcher.
Yeah, it's the same as Overwatch.
Or you can just like get the disc and it's included.
Aaron, you get it.
And then you get the multiplayer and the campaign.
What? Get what?
Yo, Bryce.
Warzone.
Yo,
What is
Bryce.
it?
It's Bryce, bro. So-
Bryce! I want to see Bryce. Bryce! Let's go, Bryce! Let's go! Let's go! Hi, Bryce.
Hi.
Bryce is my third son for
Hi,
the
Bryce.
3.5 weeks. So yeah.
Bryce, hit the whoa.
What?
Hit the whoa.
Whoa.
Hello, Bryce.
Hey.
What the heck?
Aaron, what's your TikTok?
Oh, I got you. Hey, hold up, one sec, real quick.
Aaron, we can only see your hair.
I love so.
Okay, I know. One sec. I don't know if you want to see my TikTok.
I definitely don't.
I definitely don't want to even have TikTok. This is much better than TikTok. Right
That's
here.
not. That's
sus.
That's pretty weird, champ. Not gonna lie.
Hold on.
All right, then. Lily, what's up?
Sava's cat is really fat, and I call him Piggy.
That's nice.
Yes, it is.
He
Hi,
is
Piggy.
fat. I guess.
Someone user
How about this? Is this any better?
332172009.
Ah,
Who is that? They just like our video.
That's Nicolas Cage. He's my dad.
No.
That's someone I know, isn't it?
That Sonic has seen some things.
Alrighty then. Okay then, how about the best of all?
yes.
Shrek. Oh, God damn it.
Can't get any better than Shrek.
What was that, Michael? What was that?
Actually, not true. You can.
Oh, he's gone. All right.
Whoa. Hold up. Who the, what?
Something that's even better than Shrek.
Oh, okay, it's right there. Oh, Piggy. Oh, is that Ozzy behind?
We have Ozzy.
My cat.
We have the real Ozzy up there.
Piggy. What is Piggy doing? Oh, Ozzy.
He loves you, Lily.
Peter.
I love him.
I love Ozzy.
Bro, whose cat is that?
Hi, Piggy. Oh my God. Sava's cat. It's Piggy.
Piggy, what?
Sava's.
Drew, what is that? Drew, what the? Is that Sonic? What the heck?
My brother's playing Fortnite like a nerd.
You do it, Lily.
Fortnite like a nerd.
You do that.
Hey.
You hypocrite.
Yeah, I am. I'm not playing right now. I'm talking to you guys. Piggy looks so annoyed. He's like, why am I here? You should be feeding me.
He's laying here watching fish right next to him.
Who left? Wait, who left?
Ozzy's been doing some classes lately on Zoom, and he's very smart. He's a very smart dog.
Can I see
Very
Ozzy?
He can do a handshake. He can shake your hand. All you have to do is put your hand up to him and say shake, and he'll shake it.
Can I see Ozzy?
It's cooler than that. He can eat all your food and your dog. He will eat your dog.
Yeah, sure. Actually, I'm pretty sure if we put them up against each other, Ozzy.
Ron
The
looks
thing
like
with
he
dachshunds
like
is
other
they're
two
these
cats.
little teeny things, but they think they're Doberman. They have bigger attitudes than like a
My
Rottweiler.
stomach is bigger than your dog.
Oh
He
yeah,
has
he's
the-
definitely bigger, but that does not mean he has a bigger attitude at all. Ozzy is vicious. Trust me.
Piggy is fat.
He doesn't look very vicious, but he is vicious. See? Look at that thing. Isn't it terrifying?
Look, my cat is so vicious, he will eat my fish.
That little thing right there is absolutely terrifying.
You bring him on the feet again.
Sava.
My cat is so vicious, he's gonna eat my fish. Watch him. Do you want me to open it for you? Here you go.
Ron, I had my fat cat with me when the video first started because he was laying with me. You probably couldn't have seen him because I was laying down and then he was right at me, but he was laying right beside me. Piggy! I want my cat now.
I want my dog right now.
Then get him.
Wait, guys, my cat can say hi.
I would.
Hi.
I would get him, but I got this thing.
He's like, just let me go.
Ozzy, come here.
I bet your dog doesn't weigh 20 pounds.
No, he doesn't.
My
He's
cat
not fat.
does. My cat weighs 20 pounds. Yeah.
He weighs 7 pounds because he's not fat.
What's wrong with me?
He's 7 pounds of almost pure muscle.
Sure.
This cat is out there killing the Easter Bunny, okay? He's so cool.
Yeah.
Does he poop candy?
Yes.
He said yes.
The chocolate kind.
Yeah, my cat kills baby bunnies.
Actually, Roscoe once did that at my grandmother's old house. He went outside, and when my grandmother let him back in, he had a baby bunny like this in his mouth.
Yeah,
And she was like, "No, no!" Yeah, he killed a baby bunny, and he also had killed several snakes and almost killed a badger.
Oh yeah,
He
my
was vicious.
bunch of
He
moles.
was very, very protective.
He's just laying here.
That thing looks very vicious. I'm terrified.
Are you talking about my cat?
Yes.
He will eat your dog.
Nah, he wouldn't. Ozzy would
Yes, he would.
destroy him.
What has he killed? Wait, Saba, what has he killed before?
He's killed a baby bunny and snakes and a few moles. A lot of moles.
Roscoe used to kill all of those things. Plus, he almost killed a badger once. And
Badger.
a badger, yeah. He was fighting it inside of his pipe. And my mom picked up the pipe and turned it upside down, and they both came tumbling down. And the badger went. And then Roscoe went. And then
I would probably
badger
just
got
kick the
scared away,
badger.
but
I'd be like,
Roscoe is
see
chasing
ya.
after him.
How do you get to the
I
waiting
would-
room?
I would literally just kick the badger. I'd be like,
Bryce, not Bryce. Eddie's
bye, bye, bye.
To Lily.
I don't know either.
All right, I'm going to head out. See y'all later. Bye, Lily. Bye, Savannah. Bye, everybody else in there.
Bye.
Goodbye.
Yes.
Bye.
Everybody's gone anyway, Cole. So yeah.
You're making me.
In the waiting room, I don't see him. So
I'm leaving.
Oh, okay.